If you remember what we discussed last time, I think it was mostly on asset properties, properties of transaction, and we did look at commit, rollback, save point, and we looked at certain examples of when to use commit, when to use rollback, and when to use save point. So today we are going to look at concurrency and locking plus different levels of isolation. So it's like in ACID, I stands for isolation, right? So we look at what are the different possible options for isolations that are available in MySQL. We'll also start, I think I'll be able to finish concurrency and locking today, then uh, we'll do a bit of data modeling and database design as well. This will mostly be theory part, except designing the databases using ER modeling part, which but we'll try to cover how much possible today. So before all of this, I wanted to explain one thing to you all. So let's say you have a car. So whatever you see on the outside is different, and the car can have any engine inside, right? Outside the car's outer looks like a Ferrari, but inside it has an engine of Maruti 800. It is possible, right? So you can go to a mechanical shop and ask the guy to create a outer body like a Ferrari and then put a Maruti 800 engine in this. It is possible. You can also you can keep swapping engines and the outer body as long as you want. Correct. So why I'm trying to give this example to you here is how MySQL works is also very similar. Okay. So in the outside, MySQL server is there. So MySQL server is like the external body that we are seeing, and MySQL server is constantly talking to a storage engine. Okay. So all the heavy lifting, how do we heavy lifting, all the powering the database, storing it properly, how to fetch the queries, all of it is handled by whom? All of it is handled by storage engines. Storage engine is like the engine of a vehicle. MySQL Server is like the whole body that connects to the engine. You have the steering wheel, you have the gearbox, you have indicator, light, you have whatever, everything. Everything outside is like MySQL Server and few other things. But the actual work is done by whom? The actual work is done by storage engines. So there are a lot of different storage engines. If I show you, MySQL supports a lot of them. So if you see, right, there are a lot of engines that you can see here. Memory, MRG, MyISM, CSVs, engine federated, and then in InnoDB, in Black Hole, Archive, and DB cluster. So there are plenty of engines. And then currently what we use by default is it's called InnoDB. Okay, so the engine that we're using is InnoDB. You can replace it with whatever engine you want to. The queries and all on the outside will remain the same, but the engines might support some queries. They might not support some queries. You can also write your own engine and swap it with InnoDB. So it is like saying, I'll get the chassis from the owner from outside, and then whatever engine inside, I'll build myself. So that is also allowed. But for everybody's understanding, we use InnoDB engine. Most of the MySQL by default, MySQL uses InnoDB engine. Okay, there are different use cases when you may want to use that, but we'll not dive into that for now. Okay, this is important to understand why we have different kinds of these isolation levels that we'll talk about. Isolation level, locking of the tables, and all of those are supported by the storage engines itself. Okay, so only if the storage engine supports such kind of a feature can your server give you those options. Or else even if you run those queries on the server, you'll still not be able to achieve anything because the underlying storage engine doesn't support. Okay, good. I think this analogy helps you understand what is a storage engine versus what is a server. So server basically talks to storage engine. It's like different levels. You have a client. So whatever you see here, right? This is a client. So from where I'm writing the queries. This client goes and talks to MySQL server. Then MySQL server does some pre-processing and all. Then it talks to storage engine. Now the storage engine knows how to store data, in what way it is stored, what form it is stored. And using that, what it does is it goes and talks to the actual disk. You can consider, let's say you have disk. By disk, I mean your actual hard disk. So all this data, where is it stored? It is stored on the hard disk only. Some data gets offloaded to RAM so that you don't have to actually load the whole database again and again from the disk. But for our purpose, let's say it goes and talks to the disk. So when you write a query, what happens? You type the query in the client and you send it to the MySQL server. Server does some processing. It checks whether your query is valid or no. It checks for your permissions, access levels, and all. Once all of that is done, it sends the query to storage engine. It creates a parser tree and then it sends to storage engine. Now, storage engine handles all the logic of how is the data stored, in what structure it is stored, and all, and then it fetches it from the actual disk or RAM memory, and then it gives back to the client. Okay, and all the support for transaction locking, concurrency, and isolation is at the storage engine level. Let's go back to the presentation. We'll discuss about what are the different types of isolation level. So these isolation levels are in transactions only. We support isolation levels for a transaction. So there are 4 types. We'll discuss what each of them means. So when this comes into effect is whenever I'm running a transaction. So a transaction is a set of statements, right? 3, 4 statements. How many are statements together? So how do I want my transaction to uh, any modification that I do inside a transaction? How do I want others to be able to perceive it? Like, should they see, let's say I have one transaction. So let's call it transaction A. And then I've started, and let's say I've updated the value of ID one, money. We're talking in terms of money in previous class, right? Money to 1,000, but I've not committed it. So then, so let's say I'm in transaction B. So when I do select select star where ID is equal to 1. So let's say before it was 500. So now should this transaction, so the second transaction see 500 or it should see 1,000? What do you think? Based on this, we have different levels of how we want these two transactions to interact. Do I want it to be visible? Do I want it to be not visible? So all of these options come in. So how is this controlled? This is controlled by saying, what do you say? This is controlled by saying, by selecting the transaction isolation level. So you can set isolation level to whatever you want and then decide. Okay, cool. Mm, so let's look at the first one, that is read uncommitted. So what read uncommitted means. Okay, and these isolations can be set at various different levels. So you can set it at a session level or you can set it at a global level. Global level means across everywhere. So if I set now, even if I close this and come back, and if I open Tasif's connection, or if I open, let's say, Amar connection or Steve's connection, right? So it will always be set for all of them. But if I set the transaction isolation level for one particular session, so that only exists for now. Once I close, so whatever I open now, so this is like it has done a connection with the server. So this is one session. So if I close this session, all those properties will be lost. So that is what means if I want to set a transaction level for a particular session or or the whole global level. Okay. So let us look at what is read uncommitted. So what happens in read uncommitted is there is no isolation only between the transactions. I mean, there are no locks at all. So it is like if I do a change in one transaction, then the other transaction can also see the changes. Something like this. Mm. So what I was showing. So we have this here, right? Transaction A, transaction B. So transaction one has value 100 before. So let's say in transaction A, I update one to value 200. So now if transaction B does a select statement after this, no? Select for one, it sees 200. Even though that this transaction is not committed. Let's say after this, if it goes, it can happen that this transaction, I do roll back. If I do a rollback, then I'll not see 200, I'll again see 100. But what has happened is this transaction has seen 200 here, even though this is not the actual value that was supposed to be seen, because this value was not committed only. Only once the value is committed, I should be able to see this what do you say? I should be able to see the uh, updated value, right? So this kind of a problem is called as dirty read. Okay. So how if I have to explain dirty read, what is it? So there are two sessions which are running. By session, it means two different users. Session you can consider a user. So there are two different users who are logged in, and the transaction level isolation level is set to read uncommitted. So what happens is, so transaction one started on thread one. Okay. So once it is started on thread one, I did a select statement where I set the variable to 100, and now I updated the variable to updated it to 100. So now after updating this, if I do a select rate, it will show me 100. Okay. Now if I do a rollback and then this becomes 50, but here the variable will be 100 only. Why it will be 100? Because here I've not changed anything. Okay, so it is like, even though I've not actually updated the value and I've not committed, but I'm still seeing it on thread 2. Okay, so this is giving me dirty read. Dirty read because I'm not getting the value that is actually supposed to be there. Okay, so how do we eliminate this? That only you should be able to see this value if the transaction completes. Okay, how do we do that? So that can be achieved using another option called as read committed. Okay, so in read committed, what happens is we eliminate this problem of dirty read. So how we are eliminating this dirty read? We are saying only if the transaction is completed, then show me the updated value, or else you don't show me the updated value at all. Okay, so it is like I would show you. You'll see here. Okay, so the what do you see? So on thread one, I'm actually taking the variable. It is 50. I'm updating it to 100. Then I'm committing it. So only once I commit it, right, the second person is able to see that it has been updated to 100. Okay, but this gives another problem. The problem is that, so for this thread, for the thread 2, we are inside a transaction and I didn't do anything. I didn't change any values, but I did two select queries. Then one select query is giving me 50 and another select query is giving me 100. So this is not consistent, right? So the same read I'm doing and I'm getting different values in each read. So what is it causing? It is causing me a problem called as non-repeatable reads. So what is happening in non-repeatable reads? In thread 2, in its context, it is not worried about anybody else. When it is trying to do a read, same read two times, first time it is seeing 50 and second time it is seeing 100 without any changes. So this is called as non-repeatable read. So how do we solve this problem? So to solve this problem, what we do is, so we use another level of isolation called as read committed to solve this problem. And this read committed isolation is the normal common isolation level that is set in MySQL by default. Okay. So here we, sorry, I think I read uncommitted. Sorry, sorry, I told wrong. It should be repeatable read. It is not read committed. So in repeatable read, what we do is we remove this problem of non-repeatable read. Here we are seeing two values again and again. So we remove that problem. So how we are doing that is, whenever a transaction starts, right, we create a snapshot of the table. So at what time the transaction has started, we create a snapshot. So after that, you do any time of times the select query, it will give you the same value. Okay. Only once the other one is updated and once your transaction has ended, you will be able to see the updated values. Okay. But here again, we have another problem, that is phantom read. So what is happening in phantom read? In phantom read, even though the value has updated, like here, the count, for example, if you see thread 2 is inserting a customer and committing, thread 1, it is just reading the value of customers. So before also it will see 100, let's say 100 people were there, n people were there. So before also it will see n, after also it will see n. Whereas the answer was supposed to be what? N plus 1, because we inserted one customer in the middle. Okay, so this is called as phantom reads. So to even take away this problem, we have another kind of isolation level that is called as serializable. So in serializable, what happens is This is as if like one transaction will only run after another transaction. So it's like whenever we want to run a transaction, only after the first, if there are two transactions running, only after the first transaction is completed, you'll be able to run the second transaction. Any update, it should be fine. Any update you want to do, you should only be able to read it after the first transaction is completed. And this is like the most strongest level of isolation. Okay, so we'll try to look at all these examples in code so that you'll be able to understand it better. Uh, okay, so if I want to see what is the isolation level, right, you can do select @ transaction. It's a system per variable isolation level. Okay, we have made it a repeatable read. So this was the third one in the values that I was showing you, right? So repeatable read. So by default, all other database languages have it read committed, but MySQL is repeatable read. So for this session, it is repeatable read. If I do, you can also see the global value by saying global.transaction isolation. So globally also, it is repeatable read only. Okay. So how you can change the isolation level? So it can be changed by, so if I don't, so the isolation level is changed by the following. So you have to do set. I haven't show you the, I didn't actually put it in the PPT, but so this is how it looks like, how you want to set the isolation level. So you have a set statement, and then you have global and you have session. So for global means everywhere, always it'll set whatever you want to. Session means for this particular session, you set the value to so and so. Okay. And if you don't use global and session, it will only be for the next transaction that you're executing. Cool. And then in transaction characteristics, you have this isolation level. So isolation level can be any of these four, whatever we discussed so far: repeatable read, read committed, read uncommitted, and serializable. And access mode. So you want to have this transaction level for read write or just read only. Okay. So read only means only for reading this isolation level is set. Read write means even for read and when you're writing also and when you're reading also, this is the isolation level that is set. Cool. So we'll leave this. We'll try to set the isolation level to some value and then check. Okay. So for now, let's say I set for this session, it would be transaction. And then let's say isolation level is read uncommitted. Spelling repeatable read, sorry, repeatable, not repeatable read, read uncommitted. So repeatable read is the one that is used by MySQL. Read uncommitted is I can see whatever anybody has done without even completing the transaction. So we'll set to read uncommittable first and then see. Okay, set it to read uncommitted. So if you see it has been set to read uncommitted. So for this session, that I can see by checking select global dot transaction isolation. So global is still repeatable read, but if I would do for this session, okay, session, it says read uncommitted. Cool. So what we'll do is we'll also go to Tasef's uh, table. So here I open connection for Tasef. So in this, let's say for him also we'll set the isolation level to be read uncommitted. So now let's say I start a transaction. And the transaction is into which tables he has permission. He has examples for triggers example. He also has for transactions example. So in transactions, we have what accounts is there. Okay. So let's say I use transactions example. Okay. And what I do is try to start transaction. And then I do select star from accounts. So you see balances are all this. So let's say I update balance for this table number 4's balance. Okay. So update accounts, set balance is equal to from 4,000, let's say I make it to 6,000, where ID is equal to 4. Cool. I've done an update. So I've done an update, but I've not actually committed this value. Okay. But now if I come to this person, this is local instance. This is not this another connection. So now here, if I do a let's say I do start transaction. So now if I do select, we are in trigger, sorry. Use transactions example. Do start transaction again. So now if I do select star from accounts, so what are you seeing? You are seeing 6,000, right? So even though I have not committed this value, I have not committed this value, but also the instance this side is seeing that the value has changed to 6,000. Okay, so let's say I do a rollback here. Then if I check again, now it will be normal 4,000 only. But what happened was somebody else was working on something. I was seeing their, so this is like, it is not the final value, right? So inside a transaction, you can be doing anything, whatever you're doing. If I only if it is committed, I should be able to see it, right? If because I don't know whether the user will roll it back or the user will commit it. There can be anything that can happen. So ideally, I shouldn't have been seeing that the I shouldn't have been seeing the 6,000 value that I saw, right? I should have been seeing 4,000 only. Only after this person would have committed, no? After this connection would have committed, I should have seen that the value has been changed to 6,000. But he did a rollback. So because of that, what happened? Now I'm seeing 4,000 back. Sorry, what was it? It was here. I'm seeing 4,000 back. So this is what is non read uncommitted. So even though the changes are uncommitted, we are able to read what somebody else is doing. That was it, right? So there isn't much isolation. One transaction can see changes to data made by other transaction, even if it is not committed. Okay. Oof, I've copied the same statement twice. Okay. So because of this, what we saw was we saw a dirty read happening. Dirty read because the person had just updated the value and he had not committed. He had, but I was able to see the updated value. Later on, he did a rollback, then I was seeing the actual value. But for this period of time, I was seeing a dirty read. So after dirty read, we go back to read committed. So in read committed, what happens? You will only see the changes once somebody commits something. So let's change the transaction isolation to read committed for both the sessions. Okay. So it's session isolation level read committed. I set this also to be read committed and then there's also to be read committed. Cool. If you see the isolation level for this transaction now, it will be read committed. And for this person also, if you see the, okay, if you've done this, let's take this thing and then, okay, so here also you're seeing it is read committed. So now let's see what is the difference. I'll try to execute the same set of query again. So we start a transaction on this person side. And then I update the account balance to be 6,000. But I've not done any commit or rollback. So now if I come this side to my instance, my session, and then if I do a start transaction, and then if I do a select star from account, saying 6,000, 1 second, wait. Set it to 6,000, isolation level is read committed. Okay, 1 minute. Should not be saying 6,000. Read committed. Did we run rollback? No, no. 1 second, give me 1 minute. Oh, they should come to read committed. Then I start transaction. Say it updated to 8,000. Maybe I didn't change it. It updated the balance to 8,000. Let's see this. Let's start from accounts. Hmm. Session transaction as this. Didn't I do start transaction? 1,000. For the classic connection limit 10,000. Let's assume. If I run this. Hmm. Okay. Hmm. Okay. I remember. I got it. Why? So remember there was this thing that we had uh, auto commit select. So this auto commit, right? So if it is set to one, what happens is every single line of your code, no, it is considered as a transaction and it is auto committed, irrespective of whether you start a transaction or you don't start a transaction. So what we are supposed to do is we are supposed to set this to 0. So only if you set this to 0, right, in MySQL table, will your transaction be considered as actually a transaction. So if you set it to 1, no, even though I say start transaction and I run one line, even if I don't commit it, it will get auto committed. Okay, so what we'll do is we'll do set auto commit equal to 0. Okay, so now it should work properly. I change. Okay, so let's say now I update it to 12,000. Let's do a fresh one. Okay. And let's say if I start the connection now, root. So now if you see, it should also show select at the rate, double at the rate, global dot transaction solution. The global invite is repeatable read, and then session also it is repeatable read. So this explains, right? So because I had set it to session, every time I do a new connection, right? It means that I'm starting a new session. So I started a new session. The transaction isolation has been again changed back to repeatable read. So let's say I start one more this with process 2, 3, 4. So this also will be same again, repeatable read only. If I take this and if I say select, no, repeatable. So let's update and let's do select auto commit. This should be set to 1. Okay, we need to set this also to 0. Okay, set the commit is equal to 0. This side also let's do remove this. I'm setting auto commit is equal to 0. And let's set the transaction isolation level back to read committed. Okay, set transaction isolation level to be read committed. Good. So you set isolation level to read committed. And here also I'll set his isolation level also to read committed. So now if you look at transaction isolation level, it is 1 second. Okay, sorry. Set session. Cool. So now if I look at it, read committed. Cool. So here also I have to do it for the session. I can do it session transaction read committed. So now if I say use transactions example, let's say what use transactions example. Okay, so in this case, it's using transactions example. So in Tajas also, we'll go and use transactions example. So now I'll start a transaction here. Start transaction. And then let's say first I'll do select star from accounts. Okay, let's start from accounts as 4 is 4,000. So let's say here also I do a start transaction and update accounts set balance is equal to 8,000 where ID is equal to 4. Okay, so it is updated. We select star from accounts. So it is 8,000. But now if I come here, it should show me what? It should show me 4,000 only. Why? Because the isolation level is read committed. Correct? So what is the difference that we are seeing? So previously when it was read uncommitted, what was happening was even if the other person, whoever is running a transaction, even if it doesn't update it, no, even if it doesn't commit the transaction, I will see that it has changed to whatever value he has set. But now because I have reset the transaction level and I made it read committed, only if this person now updates it, now I'll be able to see the value. Okay. So let us say now this person does a commit. So now if I do a select query, I'm seeing 8,000. Correct? Why I'm seeing 8,000? Because this person has committed now. So this transaction is completed and then he's committing it. So I'm able to see. But this is giving me one other problem, right? So let's say I didn't know Tasif was running a connection. I am actually running connection for myself. I'm actually running this session for myself. So the same, I didn't do any changes. The same select statement before gave me 4,000 and afterwards it is giving me 8,000 without any changes for this value. Before it was giving one value, now it is giving one value. So what is this kind of problem called? This kind of problem is called non-repeatable reads. The read is not getting repeat. Whatever we are reading, no, it is not repeatable. If I read once now, and if I read sometimes later, it is changing. So this kind of problem is called non-repeatable reads. Okay. So how are we solving non-repeatable reads? We are solving it by setting the connection properties, the isolation level to repeatable read. So I'll show you what happens in repeatable read also now. Okay. So let us remove all this. So if you see the current, say I end this transaction. I'm not done anything else, just say end. Okay, fine. This is okay. The transaction is, if you don't, if I refresh, it should be fine. Okay. So now if I say the transaction isolation level is read committed, so you'll make it to read repeatable read. Okay. So now if you see this has come to repeatable read, and this is the default value in MySQL. This repeatable read value is default in MySQL. Okay. So here also I'll make it table read. If I do this, repeatable read. Cool. So now we are set to repeatable read. So now if I do both of them have it. If I do a start transaction, let's say I want to update the balance of account number 4 to 12,000. Okay, and I've done the update. So now here also I've started a transaction. If I do select start from account, so it will not show me 12,000, it will show me 8,000 only. Okay. Let's say what I do a commit now. Okay. But now even if I run this now, it will show me 8,000 only. Oh, why is it showing 12,000? 1 second. Oh, I should not show 12,000. Repeatable read. Also repeatable read. Did a commit. Start transaction. Auto commit value. What was auto commit value here? 1 second. This is 0. In the old transaction level. Hmm. I did commit for this guy. Unless I end this transaction, it should not show up for me. Not ended without ending it is showing it well. So let's say I set it to 16. Say I do a start transaction. Set it to 16. Okay, I'm not doing any of this. It will not show up here. Start transaction, select start from account, start transaction, name it well. Okay. I do a commit here. Transaction I'm committing the passive. Now if I do a select start from account, it should show me the same snapshot showing 16. Okay, wait. Since I said same thing. Mm, uh, uh, okay. Okay, I'm not sure why it is happening this way, but the idea is that what happens in a repeatable read is in a transaction when you do a select query, right? It will always give you. Oh wait. I think the issue is this. 1 second. Give me a minute. I think the definition is different. So let's say I set it to 18. Before setting this, let's say I run a select query. I've started transaction here. Select query. It is 16. Now I set it to 18. Okay. I do a commit. But the select here initially was saying 16. So now if I run this, it should be 16. No, it's not working. Okay, I'll go back and check why it is not working properly. But the idea is unless I complete this transaction or I commit this transaction or I end this transaction, I should always be seeing this 4. If I do a selected, it should show me 16 because what happens is the MySQL, right? It actually caches the whole table. It creates a snapshot of the table for you. And then so that all the reads until you finish your transaction are one and the same. Here that is not happening. If you see a snapshot of select is taken the first time the select is run during the transaction and the same sharp snapshot is used throughout the transaction and the same select is executed. Right? So it shouldn't have changed. I'm not sure why. I'll take a check. I'll check this. Okay. The last one. So because of this, right? So what would happen in an ideal scenario is it's not happening here, but an ideal scenario, uh, even though I've updated here in passives connection that saying the balance is 18,000, but because the transaction type is set to read uncommitted, this person will not see that it has been updated to 18,000. So whatever was the previous value for him, he'll run it in that way. Okay. So that is this. So the last isolation level is serializable. So serializable is like every transaction is running one after the other. So how that would work is, let's say I set it to serialized should. I cannot run like if I'm let's say somebody has updated one table, I cannot run any query on the table at all. So isolation table is set to serializable. Okay. Here also set it to serializable. Okay. Let's say I do a start transaction and I update this to this value. So now if I do a select start from accounts, but let's say I want to do an update. So I also want to go and do update. Okay, wait, first let's just check this. Correct. Okay, serializable. Here also it is serializable. Okay. So let's say now I want to update it to something else. So let's start from accounts name. Let's say I update team. See, it is just running. It will time out in some time saying unable to connect to MySQL server. You can see at the bottom here, right? It has not actually done anything for neither green tick nor tick. But if I complete this transaction, no, then it will work. So let's say I do commit, then it will work. See, So once I made a commit, this update statement ran. Why it happened like that? So because the transaction is set to serializable, so reads are fine, but while writing, because this transaction is writing on accounts table, if I do try to do any modification here on accounts table again, right? So this will wait till this transaction is committed. So only once this transaction gets committed will I be able to do any modification in this transaction on that particular table. Okay, so this is what is serializable. But what happens here is all of the requests get queued one after the other, so it takes a lot of time if you use serializable. So these are the examples of different types of isolation levels. Move to the next topic, that is locks. Okay. So what do you mean by locking? So it is like, let's say, just to give a simple example. So you have a key. So let's say I'll consider each table as a home. Okay. So it's like this is one home. Let's say it is table A, and there is another home that is table B. So let's say all these have a lock. So if I as a user have a lock of table B, no, then what I'll do, I'll go open the key and I'll go inside, I'll go and sit inside table B. So as long as I am sitting inside table B, right, nobody else can come inside table B. So only once I come out of the table B saying, okay, I'm no more inside table B, can other people access table B, right? So even I can, if I have locks of both these tables, right, table A and table B, then what I can do is I'll say I'll open both the homes at a time and then I'll go and sit inside both the homes. So then what happens is I'll be present in both table A and table B. Okay. So similarly, if you have 100 logs, you can enter 100 homes at the same time. Okay. And then there are different types of locks. One is a read lock, and one is write lock. Read lock, and then you have write lock. So what read lock is like, uh, you can say it is like fake copy. So there are n number of read locks. So it is like saying, so if let's say I am one user and then Prithvi is another user. Okay. So I can also have this key and then Prithvi also can have this key. So like any number of people who want to have a read key, no, they can have the read lock. Okay. But write lock can only be taken by one person. So it is like saying read lock is like common. Any number of people who want to go inside a table can go inside. But write lock is very special. So only one person can get a write lock at any time. Okay. And other conditions are, so if you are inside, if you're having one lock, right? Let's say I took a read lock. What that means is I cannot access any other table. It is like I went and sat inside table B home. So now I cannot know anything about table A home at all because I'm sitting inside table B home. Okay. So if I want to actually go and do something in table A, I have to come out of table B. Then only I can go inside table A. Okay. And write locks are, they are more powerful than read locks. So if anybody has a write lock, they're given more precedence. So people with read locks will have to wait until the person with write lock completes his work. Okay. So why this is again used? This is used to, let's say, isolate something. You wanted to only do certain tasks on a table, or you wanted to read and you didn't want anybody else to update anything and all like that. So that time we use these locks. Okay. I can show you examples for this. So definition, it is a flag that is assigned to a table. And once you lock a table, it prevents other session from being able to access the table. Okay. So you can lock as many tables as you want, but you have to specify the name of each table. Lock tables, you give the name of the table. And if you're giving some alias to it, no, like if you're referring to a table using an alias, you have to lock it using that alias. Okay. And lock type can be read lock or write lock. Cool. So let us just see examples. So let's close both the sessions so that we don't have anything extra. Cool. So I'll use again same table. Okay, use transactions example. So now let's say log table, table your tables. What is it? Log tables. Let's say I do table is accounts, read. Okay, so read or write. You want to acquire a read lock as a write lock. So difference between lock and privileges. So privileges is it is generic. So privileges just says whether you have access to something or no. Lock means you are taking a specific access for one short period of time. So it's like I can only take a lock if I have a privilege to access the table, but lock is like giving you special access only for certain amount of time. Okay. So by default, if you don't use the lock for long period of time, or if you close the session, the lock gets released automatically. But privilege is forever. So once you have a privilege to a table, unless the privilege is explicitly revoked, you have the access to that table. But lock is for a very short period of time. If you want to, this is done so that let us say you are doing some operation. Let's say you are doing this bank only. We'll take an example. So let us say I want to read the balance of a user, and I don't want to affect anybody. I don't want to let anybody else change the values. So that time what I'll do, I'll take a read lock so that others cannot modify the value. Once I'm done reading it, I'll release the locks. Okay. So I'll just show you lock tables account read. So now what happened? I've acquired lock on table read. Okay. So if I do select star from accounts, so I'm able to read. But let's say if I do update accounts, set 4 is equal to set 94, set balance is equal to 1000, where ID is equal to 4. What will happen? It will say you have taken a lock with you have taken a read lock and you're trying to do a write, so it won't work. Okay, in this table. So if you want to do any operation, right, so you have to take all the locks in the beginning itself. So because I only took read lock, I cannot do a write. And if I go to other user and try to write, no, there also it should throw me an error. See, there is a read lock on it. So I go to this person. See, it is still waiting. So you can see it is running. So why it is running? Because somebody you can see here also it is just rotating. Because I have taken a read lock on it. So I can do release locks, unlock tables. So I run this query, no, then this will pass. See, it got in happy. So the table got updated, right? So the moment I changed the value, it got updated. So what we did, we had taken a read lock to read values. So until I release this lock, nobody else can do any modification on the table. So only once I release this lock, somebody else will be able to modify. Cool. And there is one more thing. So more than one people can take a read lock. So let's say I take read lock on accounts table. Tasif can also take read lock on accounts table. This person doesn't have access denied for user Tasif. Q. 1 second. This person doesn't have a lock permission. Q. There is some specific permission, I think, to take lock. 1 second. Some transaction permission is needed, I think. 1 second. Let's just release this guy's lock and then see unlock tables. So now if I do a lock tables account, yeah, we need some permission that is needed. Let's just search. Lock tables privilege. Okay. So you need this specific privilege. So we give this to this person. Grant lock tables. Okay, what is it? Grant lock tables to passive local host or um, transactions example dot stuff on. Okay, so given this permission to him now, I probably have to do refresh. Let's close this connection. Let's open the connection again. Sorry, I opened the same one. Sorry. Hmm, so so now it should be, let's say I need to use transactions example. Hmm. So I should be able to lock. Okay, so I've locked the table now. And here also I have locked the table. Let's say it locked the table. So what happened? Two people at a time can take read locks. Okay. So now if somebody wants to update, right? Only once we both release our read locks, no, will they be able to update? Okay. So like for example, let us take a third user. Amar. I don't know this people's password. Let's reset Amar's password. Set user ऐसे होता है क्या? Password. I don't remember the syntax, man. Update password. MySQL. Alter user identifier. Okay. Where user, your name is what? Amar at the rate localhost. No? Okay, cool. So we root up. Table user was not logged. Okay, I have to unlock the table. Okay, so we have given this. So now let's say I do a lock tables. So I've taken a lock table. Tasif also has taken a read lock. Now let's say I open this. Well, let's also give permission. Grant lock tables on transaction example, comma, uh, select, comma, insert, comma, update. Okay, to Amar at localhost. Yeah, एक second. Okay, so now I've logged this table. So I go to Amar. So I do root. So you should have example to transaction example. So first thing is you can read a table if there are other people who have taken a read log. It doesn't create any problem. Transactions example. Okay, so let's start from account. So I can do a read. Read is not blocked. But if I try to do an update accounts set balance is equal to 1000, where ID is equal to 4. So it will be stuck. How long will it be stuck? It will be stuck as long as the table is not lock is not released. So I should do unlock tables. So once you do unlock tables, all of the tables get released. So now this is locked. But if you see still this is pending. Once I release this person's lock also, it will get done. So ये हो गया. Got updated, right? So this is about read lock. And let's say when you're taking, I've taken lock on accounts as read, but if I do something else like select star from accounts as A1. So I use an alias for this table. Okay. I take a lock read, and then if I try to use alias, it will throw me error. It will throw me error saying A1 was not locked. So if I want to take the lock on the alias, so what I have to do is lock tables account as A1 read. So now I do this, now I can run this query, right? So if I'm taking an area, lock on an alias of a table, so I have to specifically say this. Okay. So and I can also take more than one lock, more than one lock on a table. Let's say I take read on accounts, and let's say I also take the table that is email to specify what I want, say read. So now what I've done is I've taken a read lock on two tables. So I can access these both tables. Can access accounts, can access email, but I cannot access phone number because I've not taken a read lock. So only once I have all the locks now can I be able to use those all the tables. Cool. So let us do unlock. Now let us look at read write locks. Okay. So if I take a write lock now, other nobody else will be able to take a write lock. That is first thing. So do a write. So I've taken a write lock. So let's say I have done taken a write lock. Let's say somebody else wants to take a write lock. Tasif also wants to take a write lock. Okay. So you see the lock itself is waiting. Why is it waiting? So 1 second. Wait, I'm not able to see your questions. Okay. So why is it waiting? It is waiting because this person, I have taken a write lock on it. And at any point in time, there can only be one write lock. Cool. So let's say if I release this lock now, if I do unlock, then this person's lock gets granted. So his right is granted. So when one person has a write lock, right, somebody else can still take a read lock. That should be fine. Oh, sorry. Okay, sorry. Read lock also is not there. So only if you have a write lock, then even in read lock, I'll have to wait. Okay. That is also not possible. So here again, I'll have to release. So then the read lock comes through. So in write lock, the advantage is you can do a write. You can do a write on the table, and when you're done a write lock, nobody else can write into the table. So let's say, like for example, I do a write lock here. So I've done a write lock. So I can do an update. Let's say I try to do an update without taking any locks. It is also waiting. Why? It is waiting because somebody else has taken a write lock. So only once this write lock is closed, I'll be able to update it. Okay. So why we need these locks is, let's say when we want to do some special transactions, special actions onto the database such that nobody else is able to access that database for some time. Say like Hydra, let's say you're doing account related actions, or let's say you're doing booking related actions. You don't want, when one ticket is booking, you don't want other ticket to be accessed. So in here we are having at a table level, but you can also do it specifically at row level and all. Okay. So that's it for logs. I think there is not much after this. There are read logs, there are write logs. So you can you can have multiple read logs. Then when you're having a read log, you cannot perform a write. And then if the session is terminated or if you close the session, all the logs get released. And write logs are higher priority. So that is why if there is a read log, then and if somebody else accesses a write log, their write logs get granted, and read log has to wait until that write log is completed. Mm, so when if you have a write log, you can both read and write, and only that table who has a write log can access that table. Okay, so unlocking is again table. You just say unlock tables. Okay, yeah. That is it for locking and what do you say? Concurrency model and locking as well. So we would covered Implicit lock. So row level locking is not supported in the storage engine that we do. But there, what you would do is, so how we are locking a table here, there we will lock specifically one row and complete it. This is done. Then, so SQL versus no databases, I'll cover these at the end. I've explained parts of how SQL internally works, what are storage engines, and all, but this will cover at the end. So these three, we'll probably take it in the last class. So for now, we'll start with this. What is data model? What do we have to, what are we doing in a data model and all? But this probably is mostly theory only. Will not be much of, oh, what do you say? Not, will not be doing anything on the workbench. Okay. So I'll stop here for a while. If you people have any doubts and all, you can ask me.
So, Guru, what is the difference between lock and privileges?
I explained, right? So lock is, so first thing, to acquire a lock, you need to have a privilege. Okay. So if you want to, let's say, acquire a lock on a table, first thing is you need to have, you want to read or write, then you need to have select, insert, and update permission on the table. Only then you can take a lock. And the other thing is, so privilege is always there. Okay, it's forever. Privilege is forever. Unless you explicitly go and remove, privilege is always there. But lock is needed only in special cases. So in special cases, when you want nobody else to access the table, or when you want nobody else to access a particular DB or a row, you take a lock.
Okay, so this kind of lock we will do it in backend itself, right?
Yeah, yeah. You will request a lock in the app itself directly, and then you will release the lock once you finish your work.
Okay, one more doubt. So is it used for the multi-threading, I mean, for the synchronization process, or is it different?
Yeah, yeah. So let us say there are multiple threads which are requesting, which want to update the data.
Hmm,
So then it becomes difficult to let's say serialize those threads, right? Who has to go first and all. So
right.
then what happens is one person takes a write lock. So once they finish their work, they release the lock, then somebody else can take it up and update on the latest data. So that, there is no, two, three people are not seeing the same data and updating at the same time. So it's like one after the other.
Okay. So what is the difference between synchronized and lock? I mean, which one is preferable actually?
So they both are two different things, right? So
Hmm.
synchronized, you're talking about that serialized that we talked about,
No,
not
no, no,
synchro.
no. It's in the multi-threading concept. We will use the synchronize keyword for the one person
In
allowing
Java,
the. Yes, yes,
you're
yes,
saying in
yes,
Java.
yes. Yeah, in Java.
So lock does not necessarily mean it is synchronized means it is running on one single thread.
Mm-hmm.
Okay. So lock and synchronize are different. Lock is actually taken not on threads. It is actually taken on variables or some objects.
Okay,
Let's
okay,
like for example, let's say I have a variable whose value is 10. Okay. So if two, three threads are trying to access that variable, what I can do is if one thread takes a lock, then other threads cannot read that variable because it is being locked by another. Let's say there are three threads A, B, and C, and there is a variable called hello. No, there's a variable called message. So if A takes a lock on message variable, then B and C cannot read that message. They cannot read that variable at all. Only once A completes the work and it releases the lock, B and C can read it. This is what is taking a lock. Whereas synchronize keyword, it is used to say, I want a I want a piece of code to execute on the same thread.
right. Okay, okay, okay. Good, got it.
Okay, cool. So it is not this lock is different from what lock in Java. See, almost similar, but synchronize is not there in what do you say here in MySQL.
Hmm. Correct. Okay, okay.
Mm. Okay, cool. Anybody else has anything?
Sir, can we see who has locked the particular table?
Yeah. That
Which
is,
user?
I think that is visible. That is visible. I think there is a command for that. 1 second. Keeps opening. So if I do show process list, transaction example, waiting for table metadata lock. Is he waiting? Let's say I do a let's say I do a write lock here. I'll take a write lock here on one table, accounts pay. Okay. And then let's say this person, let's say Amar tries to take a read lock. Tasif tries to take a read lock, let's assume. So writer will not possible. Should directly straight away say, okay, it is also waiting. So let's say if I do show process list, this will show me all the processes that are running and waiting for lock or anything. No? Okay, this person doesn't have that. Let's see here. Okay. Says waiting for lock tables. No, this is not that. Let's just check. Wait, I'm not sure what exactly will be the command. Give me 1 minute. Second. Show open tables. See. Tables. Where can I do where here? Where no? Constraints account in use name log. Not showing. Go to this person will do. Says in use name log is again not there. There should be a direct straight ahead query how to find out this lock in the table. Lock table insert. Show process list waiting for this is okay. This person is also saying this only. I'm not very sure about what other queries you can find out to see what are, but I'll let you know tomorrow. Okay.
No problem.
Anything else? Okay, we'll go ahead with the remaining. I'll try to cover a few topics. Okay, what is the PPT? So, what is a data model exactly? So, whatever we are discussing the other day, right? About Swiggy or what are the Twitter. So, data model basically means it is a kind of representation which of the real world system. So whatever is the system for which you're trying to design a database or a system or any real world scenario, everything that is needed to describe the whole database or describe the whole scenario and understand what are the requirements. So that can be called as a data model. And why is it necessary? It is necessary because once we have a data model properly, only then can we actually start implementing it in any database of our choice. And it is also, it makes it easier to store, process, and take out all the information. Okay. And data model can be in various different forms. What we discussed in the very first day of the class. So it can be a relational, it can be a network, it can be object oriented, any type of representation of data. So it doesn't necessarily have to be a relational database. It can be any kind of database. It is just a way to represent real world data so that we are easily able to identify the requirements were easily able to process the information properly. Okay. And why do we want to uh, describe? Why do we want to use data models to describe everything? Because it is used it is used so that we have to properly identify what all are the entities and what all are the relationship between different entities. So we had looked at Twitter and we had realized users are one entity, and then the tweets can be another kind of entity. So we need to find out what is the relationship between all of them, and we need to identify how we want to organize all of that data, right? So because of that, we use data model, and we try to identify what all are the requirements of a data model and design a specific database for it. Okay. Goal is, sorry, this keeps asking for a password. Let me get back. Yeah. So the goal of data modeling is to make sure that whatever are the data objects that are there necessary for a database, they are completely and accurately represented and data modeled and nothing else. Okay. So what all are the terms inside a data model? The most basic, the first important is entity. So entity means it's an object. It's a real world object. So in case of Twitter, tweet was an entity because it is a kind of object, right? And user is an entity. So user is also a kind of an object. So those were only the two main entities. Everything else was surrounding them only. So whatever is surrounding them, no, those are called as attributes. So entities have certain attributes. So if you take, for example, a bank, in bank, user is an entity. User, I mean, customer is an entity. The customer will have a lot of different property attributes or properties like he'll have his username, he'll have his account number, date of birth is his property, his account balance is his property and all. Okay. Then a relationship is, what is the relationship between two entities? Like for example, we had user and we had tweets, right? So what is the relationship between user and tweet? So a user tweets. So it's like a user can produce as many tweets as he wants. So the relationship between user entity and tweet entity is that the user can produce tweets. Okay. And what is the cardinality? Cardinality means what is the kind of mapping that we are seeing. Like for example, if you see the mapping between a user and tweets, it is one to many, right? One user can have more than one tweet. One user can have any number of tweets that he wants to have. Okay. And reverse, if you see, if you have to see the relationship between tweets to user, many to one. So many tweets can be pointing to a one user only. Okay. So that is cardinality. Cardinality basically means what is the kind of mapping that is between that is there. The quantitative mapping. How many number of one entity will map to the other entity. Okay. So that is what is cardinality. So like for example, if you take this is a fruit, right? This is apple. So what are the properties you can see of an apple? So apple, let's say one can be size. So there are small apples, there are big apples. Other is color. You will find apples which are green in color. You'll find apples which are, let's say, another criteria can be how many days the apple is. It has been plucked from a tree. Fresh, stale, is the apple gone rotten? So that can be. So these are all the attributes that will be there for an apple, right? So then, what other thing related to apple can be an entity? So you'll have an apple tree. So apples are grown on a tree, right? So tree also becomes an entity, or apple tree becomes an entity. And then what all attributes an apple tree can have? It will have maybe the height of the tree, and then let's say what is its yearly yield. That can be a property. And then let us say we can say how often do we water that tree. That can be one of the attributes of the tree. And how old is that tree? Is it 10 years old, 20 years old? So that can be an attribute. Okay. So tree is one. If you look a little bit even more bigger, then you'll have an apple farm. So from apple grows an apple tree, and then it again grows on a apple farm. So what all will be the attributes of an apple farm now? So how many people are working in that farm? What is the area of the farm, how many trees are there in the farm, what is the yearly yield of that farm. So again, this becomes an entity, and then this entity will have a lot of different attributes. So now how will you map all these three together? So the mapping will be apple is a entity which grows on an apple tree, and apple trees are mapping between apple trees and orchard as apple trees grow in an orchard. So mapping between orchard to apple tree is one too many. One orchard can have more than one apple trees. And again, mapping between apple tree to apple is again one too many. In one apple tree, many apples can grow. Okay, that is it. So this is I think nothing special. So in data modeling design, right? So there are three levels. So one is the first three stages you can say. First stage is conceptual design. The next stage that comes is the logical design, and last is physical design. By physical, I mean actually implementing it, be it a database or anywhere you want to implement it. Okay. So in conceptual design, what we do is we just try to get all the points that we need, like high level description. It is not actually mapping anything directly, but let's say just an overview. Let's say we want to identify what all are the entities and what all are the properties, so that you can consider it as a high level model. We don't dwell anything deeper. We just want to have a overview of what all are the requirements. Okay. So what can you say are the goals of conceptual data modeling? One is you just want to take the properties of all the let's say whatever is the data, whatever the entities, right? You can take their properties, and then you want to identify and define all the relationship between each properties. And then this is okay. Not doesn't make sense much. That is the basic idea. So now this is more of like a conceptual design. So from conceptual design, we come to logical design. So now logical design, what we start doing is we start actually defining these relations. So we write down what are the entities, what are their attributes. We start mapping what is the relationship between each of them, what is their cardinality. We also start mapping what are the constraints. Okay. So once we do all of this at the end of a logical data model, whatever we get to, that is called as it is called as an entity relationship model diagram. Okay. So when you map all of this properly, right? Saying these are the entities, this is the relationship between so and so entity and all that. So then what you get at the end of the this whole logical data modeling exercise is called the entity relationship model. Cool. So its goal is again to say what do I want out of logical data modeling? We want to take the conceptual data model that we designed, that we thought of, and then convert it into a fine, let's say very specific. It is no more overview. It is very specifically what is the relationship between each entity, what is the relationship between each attribute and all, which are the what are the actual attributes saying, any properties of the attribute and all of that. Okay. So there are different tools by which you can design these entity relationship diagrams. So at the end, it should look something like this. So if you see orchids is one table, and then apple tree is another table, and apples is another table. So each entity has its own table. Okay. If you see the key icon, right? So all of those are primary keys. And then if you see the diagonal, blue diagonal, all of them are what do you say? Uh, they are normal attributes, and then whatever is the pink one you see, they're all foreign attributes. So they come from somewhere else. And the connection between these two tables that you see, it is a kind of, it depicts the cardinality. What is the mapping between this table to this table, and here, what is the mapping between this table to this table? Okay. And then, so what are the advantages of having such kind of diagrams? One is improved communication. Why I would like to say that is because when you have a diagram which depicts your whole requirement properly, you don't have to sit and explain to somebody in the air saying, oh, this, I want, these are all the properties, I want this, I want that. So you just have to share the diagram over to them, and they'll have a look and they'll understand. And also because it is standard language, you don't have to sit and define something on your own and say. So it's like saying key. This key means some values. This key gives me some meaning, and the other person who will see this will know that okay, what does he mean by this key? And this it is like we have defined certain symbols which have a predefined meaning, and they can make use of the symbols and identify what we are trying to convey. That is one, and it helps in better data modeling and data integrity because we don't want to repeat any data in different places. So creating this helps us. Whatever is the like, I wouldn't put date planted for a single apple tree in all the apple trees in our chart because date planted for a apple tree belongs to that specific apple tree only. So the integrity of the data is maintained. And also we can do a better database design because we have the whole structure with us. We'll just have to implement, write the SQL queries for this to create tables and all. Okay, that is one thing. So after entity relationship diagram, what happens is, so what is the context? As I explained, entities effectively become table, attributes become their columns, and then a relationship becomes keys and constraints and all. Cool. Uh, so this also we have discussed. There's something. So this is again relationship we discussed. So weak entity can be considered as something which depends on some other entity. It doesn't exist on its own. Like for example, if you take friends in a uh, friends, let's say in Twitter, in Twitter we have followers and following, right? So that can be considered as weak entity because it does not exist on its own. It is a combination of few other values. In attributes, we had discussed this key attribute is what are the important, like primary key is considered the key attribute. Composite attribute is it is derived of 1, 2, 3 values, I think. Let's look at the definitions. I forgot to remember that. Okay. This is again we have looked. So here you can see employee becomes an entity and then department is also an entity, and this is the relationship between them. So so what does regular and strong or weak entities? Regular entities have unique identifier, they have a primary key and they exist independently. Weak entities do not exist independently, they are dependent on some other entity. Okay. So the example I gave you, right, of the followers and following, that is what I meant. Very similar. So like here an example, installment, let's say you have loan and you have installment. So an installment can only exist if a loan exists. So what happens here? Installment becomes a weak entity. Okay. In normal entity relationship diagrams, weak entities are represented by two boxes, two double rectangle. Okay. So attribute can be any properties of a particular entity. So where you see ID is an attribute, name is an attribute, age is an attribute, phone number is an attribute, and then we'll have different attributes and different types of attributes. As we discussed, ID here becomes a key attribute because it is used to represent this whole entity. So this entity is identified by this ID, so it becomes a key attribute. And then we have composite attribute. So composite attribute is a combination of few other attributes. For example, name here becomes a combination of first name, middle name, and last name. So this does not exist on its own. It is a combination of these three, so it becomes a composite attribute. And then we have multi-valued attributes. So what multi-valued attribute means is you can have more than one specific value for a attribute. Like for example, addresses. If you are in Swiggy and you can have more than one addresses, as many addresses as you want. So that becomes a multi-valued attribute. Phone number can be a multi-valued attribute. Okay. And then we have derived attribute. So if you take a student, his age can be derived. How, let's say you have a birth date already. So you don't need to take his age also that time. So at any point you want to calculate his age, you already have his birth date. Use that to find out what is his age. Okay, so this becomes a derived attribute. Okay. And sorry, relationship. So we talked how we use how we define a relationship as it is defined by a rhombus box and whatever is a kind of relationship that is mentioned in that box. So here teacher teaches the student. So teachers becomes a relationship and the two entities are teacher and student. Then there's also cardinality. What are the different cardinalities of a relationship? one-to-one. You can go look at the slides afterwards. I'll just go through quickly. Then you have one-to-many. So like for a scientist can do many inventions. So it is one-to-many, and then you'll have many-to-many. Many students can enroll in one course. So your course is one. In one course, there are many students who are enrolled. So this is one-to-many, and you can have many-to-many. So different employees can be assigned to different projects. So it becomes a many-to-many. Okay. So just to revisit what we discussed. So we have three process step. Data modeling is again three-step process: conceptual, logical, and physical. And then conceptual and logical, you don't actually, you just design the entity relationship diagram, and conceptual, you just think of whatever is needed. Then we use ER diagrams to capture what are the entities and all. And ER diagram is like a proper way to document your design properly. Okay. And what are the steps? So far, whatever I discussed, it encompasses that only. We first identify the entities, then we identify what is the relationship among each of the entities. Then we determine what is the mapping between them and what are the cardinality. Then we designate keys, that is primary key, foreign key, and all. We list all the attributes of all the entities, and then if we want to specify some constraints and all, this comes at the way at the end. Okay. So this is mostly theory specific, and we have already discussed most of the stuff when we're actually reading about primary keys, foreign keys, or let's say we wanted to add constraints like unique constraint, check constraint, So this is just a way of consolidating all of that and then designing how we want to design the database, deciding how we want to design the databases. Okay. So there is some examples that are there of how to design all of this, how to apply it for certain specific databases. So what we will do is we'll try to we'll just try creating entity relationship diagrams for this. We'll do that in the next session. Come on.
Guru,
Yeah, good.
there is a one question. I
Hmm,
can't
hmm,
able to come up with the answer. So the table was it's an kind of arrival departure one. Okay, the table
hmm.
was.
Can you share the question so
Uh,
others can
uh,
also take a look at it?
I don't have the question actually.
Okay. Explain it. We'll try
Yeah.
to see.
Okay. So the table will contains ID from 1 to okay
Hmm, hmm,
and rate. Okay.
hmm,
So what is the question is I need to remove the duplicate. I mean, if I comes from Chennai to Bangalore, okay,
hmm,
and Bangalore to Chennai, there are two
hmm.
entries, okay, but I need to remove that because it repeats twice, right?
Chennai to
How
Bangalore, Bangalore to Chennai. You want to remove that and then you don't want to keep both of them, or you want to keep one of it?
one of it, either one of it. The rate will be same, right? Chennai to Bangalore,
Okay.
Bangalore to Chennai. Both are same. So I need to remove one. How I can do that?
So you basically want to create a new table and then keep only one of it.
Yes, but how I can retrieve the one? I mean,
Okay.
in both have both are different, like right? From and
Hmm,
to
hmm, hmm, hmm,
both
hmm,
are
hmm,
different,
hmm.
but I need to remove either of the one. How I can do that?
Okay, 1 second. Say we'll create a table and then just do it. Hmm.
Okay.
So let's say you have MySQL. Hmm. To unblock tables. My find something. Okay. So create table. Let's say prices, and I'll call it city one. Why is it asking me password every? So then this close this. Okay. So city one, and then I'll do a what do you say? It is of type varchar size 50, and then I have city two. Here I can this also size 50, and I have a price. So it's the type decimal, it's 10. Okay. And I'm saying the city 1 and city 2 is unique. At least you cannot have same value again and again. So I'll call it unique. QUE city 1, comma city 2. Unique. Does this Is this definition okay for your
Yes, yes,
question?
yes. It's fine.
Okay. So done. So let's say I do insert into prices, values. Say I insert Bangalore to Chennai is 1,000 rupees. This will go in. And even if I do Chennai to Bangalore, this will go in. Cool. So now if I do a select star from sorry, select star from prices, it will show me both. Correct, right? So
Yes.
somehow I want to do I want to get these column, these values properly. So what we can do is, um, so let's say I have we can use stored procedures to do it. So what I'll do in a procedure is I'll do a select statement once. So then I'll create a cursor. Okay. And then I'll start iterating from each one of the rows. So first I'll take, so it's like, mm, so this is prices table. To from and then value. Okay, from A to B, it is let's say 1,000, and B to A is also 1,000. C to D is 1,500. Okay, so I'll create a new table. Price updated, and then what I'll do is, so inside a stored procedure, I'll create a cursor, and then I'll open a select. I'll do a select query, and what I'll do, I'll take this, then I'll check, does this combination exist or no? A comma B. Okay, inside this table. So if A comma B exists, then I'll not add it. Let's say A comma B did not exist. Then I will also check, does B comma A exist? Okay. Either if A comma B exists or B comma A exists in this table, no, then what I'll do is I'll not add it. Okay. So only if neither of these exists, I'll add this value. So it'll be like first time I'll add A comma B, 1,000. Next when I come to B comma A, I see that A comma B is already present. So A comma B is present, I'll not add it. I'll just go to C and D. So C and D, nothing is present, I'll add C and D to 1,500. But is this possible via your question, or they
Yes, yes,
only
yes, yes, yes.
they're specifically asked to do something?
No, 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 no. This is what exactly they are asking.
So you can just let's see if ChatGPT will give us the answer. This is this no. So no, this will not. Sure, we can only write. We'll write why to ask somebody else. Let's say I do a create procedure, convert to table, convert to distinct prices. Okay, we don't take anything inside because we don't need anything. Have a delimiter. Right. So what this will do is begin convert to distance, begin declare cursor. How do we declare a cursor? Let's say I'll call it price cursor on for Can anybody help me? I've forgotten the syntax for declaring a cursor. Cursor example in MySQL. Okay. Declare cursor for, okay. So it should be declare cursor name, price cursor, cursor for, and then what is the segment that you want? Select star from. Yeah, I don't even have to do this much, I think, man. Wait. Oh no. Distinct. If I do A comma B, then it will get, because both of them are distinct. No, that wouldn't work. Sorry. I was thinking of something else. Select star from what is this table name? Prices, no? Prices. Okay. So I've declared a cursor. Then what we do is we have to iterate over all of the values. Continue handler not found. This continue handler is if I don't find any more values inside my table, then I'll do this. Declare continue. When I don't find any more values from here, no, then we run this. Set finished is equal to 1. This is fine. So we open the cursor, then we'll do some logic inside. Let's write that logic here. Okay. Pull it down. Pull it down. So open price cursor. Okay. So let's say the name of the loop is add price. Okay. And then end loop add price. Open price cursor, close price cursor. Okay. So this is correct. So fetch current email into email address. Current email address. How's that done? 1 second. Give me a minute. Sorry. Select email from employees. I don't want to do this. How would I take it for multiple values? Name, cursor. And student cursor. Oh, you can only take one value. Okay. No, it should not be. One second. Huh? Multiple columns. Okay, so you have this, and then you do it's next from test into no. Star. Okay, it is just like this. Yeah. Dot. Cool. Fetch current object. Fetch. So this will be price cursor into, let's say, what do we call it? Price. Okay. So for each price, we take this. So if at any time we finish become 1, then leave add price. Okay. So then what we do is close price cursor and $. Then let's remove this for now. Script but set by n I succeed finished is equal to 1. Okay, so in this we'll have to write our whole logic now. So what our logic will be? Logic will be, let's say I declare one more variable that says found value, okay, of is of type integer, default is 0. Okay, so then what I'll do is I'll come here, I'll do select count star from what is the name of the table, prices, where what all columns do we have? Prices, city 1 is equal to city 1 is equal to price row dot city 1, and city 2 is equal to price what is it price row dot city 2.
It should be
Okay,
reverse, right? City
it
2
is,
and
that is okay, even if it is reverse or
okay.
that's fine. Where this is true, or I do add, or I'll do this.
Oh,
City 2 and then city 1.
1.
Okay, so if any of this is true, then I'll not do anything. Okay, if so it will become like if into I have to put this into something, no? Into this what variable declared found value. So if found value is equal to 0, then insert into, so let's say I create a new table, create table distinct prices, select star from prices, limit 0. Okay, so this created a table for me. So I'll add it into distinct prices. Set into distinct prices values. I will do city 1 price row comma city 1 comma price row dot city 2 comma uh, price row dot price.
R capital.
It's fine. This is but this in Windows, no, it is. I think in Linux, you have to specifically even variables name it properly. I've seen in Windows system it works. Okay, you've done this. And if okay, so looks like it is done. Let's do that. Semicolon. Good. Let's say I run this. Does it say unknown system variable finished? Set finished. Where else are we using finished? If finished. Okay. Declare finished uh, int default is equal to 0. Variable or condition declaration after cursor handler. Okay, so this should be before all. I think. Undeclared variable price row. Price row. Okay. PRIC, fetch price cursor into price row. Oh, okay. I think we have to define those also. Hmm. Price row city 1, row city 2, price row price. Cool. I think we can't directly get all of them, so I'll doing it this way. Price row city 1, row city 2. Okay. And we'll insert it like this. So price, if I read this, and then declare finished value, found value 0, declare price row city 1, price row city 2, varchar 50. Okay, price row price. Okay, so this was created. So first, let's add as many values as possible to this prices. So let's start from this. Bangalore, Chennai, Chennai, Bangalore is there. Let's do one more insert. Insert into prices, values. So I add one more, that is Bangalore to New Delhi, Mumbai is 2000. Okay, let's say Chennai to Ladakh is 8000. Okay, so this much enough. Let's say we add one more repeating. Okay, Mumbai to Delhi is 5000. Same Delhi to Mumbai, same 5000. Cool. So now if I do this, correct. So showing all of this, let's run this procedure. Call. Uh, highly unlikely first time it will pass. Convert to distinct prices. So we run this. Let's say what error it throws. Oh wow, we didn't throw any error. So that means either you've done it full right or full wrong. Select star from DISTINC distinct prices. Okay, we have done it wrong. So it is not actually emitting anything at all. So what we will do is let's see if the count is coming properly or not first. Cool. So if found value is 0, then insert. Okay, found value is 0. Found value by default is 0 only. Found value is 0. If you don't find something in from prices, then insert into distinct prices. Oh, okay. Sorry. There should be what? There should be distinct prices, right?
Yes.
So if I'm checking in the same table it is present, and it will always be present, right? Hmm, what do? I have to drop, convert to distinct prices. Drop procedure. Cool, it's done. So now let's do a create procedure. Second, check to create procedure. Succeeded. Call convert to distinct prices. So let's start from distinct prices. Correct, right?
Hmm. Yes.
So we didn't get we got Bangalore to Chennai correctly. We didn't get Chennai to Bangalore. We got Mumbai to Delhi correctly. We didn't get Delhi to Mumbai.
Yes.
Okay. You want this piece of code? You can share it if you want to. There should be an option to create paste, no? Yeah.
Okay. Thank you, Guru.
Yeah, cool. No issues. So we will drop for today. I'll not be able to take a session tomorrow. I'm traveling back to my home. So I'll take 2 sessions on Thursday and Friday and we'll complete by Friday. Cool.
Okay. Okay. Thank you.
Okay. Thank you, folks. Have a good day.